to be late. Did I forget something?
I still got 15 minutes. You know what? We've been using a mirror for so many years now, but up until now, I can't stop wondering how it works.
I agree with you. It's as if there's some magic happening in it.
Do you want to know the secrets behind mirrors?
Yes.
Come on, and let's explore the science behind plain mirrors. A mirror is a polished surface that forms images by reflecting light. Light itself is what makes vision possible. We see things because light bounces off them and into our eyes. When light hits a surface, it reflects or bounces back. There are two types of reflection: regular and irregular. Irregular or diffuse reflection refers to light bouncing off on rough surfaces like rocks and walls, causing light to scatter in different directions. Because of this scattering of light, no clear image is formed, making the surface appear dull or blurry. On the other hand, regular reflection refers to light bouncing off on smooth, shiny surfaces like plain mirrors, where light is not scattered, forming a clear image. This mirror is a smooth, flat surface, which means it creates what we call regular reflection. The light rays bounce off at the same angle they hit the surface. There are two important laws of reflection. Number one, the angle of incidence, or the angle at which the light hits the mirror, is equal to the angle of reflection, or the angle at which it bounces off. And number two, all three of them, the incident ray, the reflected ray, and the normal line, or the imaginary line perpendicular to the surface, lie in the same plane.
So the light from my face hits the mirror and bounces back to my eyes, creating my reflections?
Exactly! Now, let's talk about incident and reflected rays. The incident ray is the light approaching the mirror, and the reflected ray is the light leaving the mirror.
But my reflection seems to be behind the mirror. How is that even possible?
That's because you're seeing a virtual image. Take a look at this. The light rays appear to be coming from behind the mirror, even though they're not actually there. The image is upright but laterally inverted, meaning your left side appears on the right of the reflection and your right side appears on the left.
Oh, I see. That's why I look really different in the mirror.
You're right. The image is also the same size and distance from the mirror as the actual object. Now, let's consider what happens when we have multiple plane mirrors. If we place two mirrors facing each other, we get multiple reflections. The number of images depends on the angle between the mirrors. If they are parallel, 0 degrees, we get an infinite number of reflections. At 90 degrees, we get 3 images, 2 complete and 1 composite. And at the other angles, we get different numbers of images. This principle is used in kaleidoscopes to create beautiful symmetrical patterns. Before we end our discussion, let's describe again the characteristics of images that are formed by plane mirrors based on the type of image, orientation, location, and size. The type of image formed by plane mirrors is called virtual image. A virtual image is formed when the ray diverges when it leaves the plane mirror. When you stand in front of a mirror, a virtual image is formed. The image is formed when the light rays extend behind the mirror. The orientation of the image is upright and laterally inverted. This means that the left side of yourself appears on the right side on the reflection, and the right side of yourself appears on the left side on the reflection. The image is located at the same distance from the mirror as the actual object. To sum it up, the image and the object in plane mirrors has the same characteristics except that the image is seen as laterally inverted.
That's amazing. I never thought about mirror in this way.
We've understand it much better now. Thanks.
You're welcome. Remember, mirrors are not just tools that we use to check our appearance every day. It's a great example of how light interacts and behaves in the world around us.
I hope you learned something today, AGHAMazing students. Keep exploring, stay curious, and never stop discovering. See you next time!